Welcome to the part 7. In this part, we will be using NESTJS Framework and GraphQL together to persist our data into Postgres database. And we'll be focusing more on setting up GraphQL and creating mutations and queries and writing the resolvers. GraphQL is a query language for APIs. It provides runtime for executing queries. Usually, we send in queries using a JSON format. It allows clients to request exactly the data they need, making it more flexible as compared to traditional REST APIs. And GraphQL typically exposes single endpoint for all queries and mutations. Mutations are like update, delete, and create operations. GraphQL itself is a specification. There are many libraries and tools built around GraphQL that help implementation. GraphQL libraries are available for several different languages, and it also allows real-time updates through subscriptions. I have created setup nest GraphQL project.batch file to collect all the commands that I need to set up GraphQL Nest.js project along with Prisma. And in the top, I am scaffolding a project backend Nest P7 using the Nest CLI. And after that, I am switching the directory and getting into the new backend Nest project directory, creating a common folder there, installing several dependencies that include GraphQL, Apollo Server, Apollo, and GraphQL, and some validation libraries and transformation libraries. Then I have npm installed like Prisma client and then Nest.js Prisma and a dependency that is required by Prisma. And then I am installing the Prisma. In this section, I am getting into common directory and initializing the Prisma for creating the schema file. Let's execute this. This setup will take some time. Everything is installed. I have a common directory, Prisma, and Prisma schema. I'll edit it later. I have .env file with placeholder connection string for Postgres SQL. Let's generate resources or business features. I'm using GraphQL code first approach, and similarly for orders. Now for customers, I have here customers, orders, and products. The difference is that you can see resolvers in place of controllers here in GraphQL project. Now let's go to Prisma schema. We have already seen that how we can write Prisma schema in earlier parts of end-to-end series. I have the client, Prisma client JS, provider is Postgres, and I am picking my connection string from .env file that is located here. And then I have models for order where I have specific constraints and relations. So in this schema, I have relations and reverse relations as well. In case of customers, customer can have many orders. If I go to orders above, I can see a reverse relationship here on customer ID. And similarly, order has many order items. And if I go to the order item, I have a reverse relationship on order ID. UUIDs are used as primary keys and they are generated upon creation of order item or customer product or any other entity. So we will use this schema. I have done another thing that I have added connection string. I'm using the same container setup that I used in part 6 with Postgres and pgadmin. I'm providing in the username and password and server URL along with the database name, which I have changed in this case to test database 7 by creating a new database using pgadmin. After creating Prisma schema, I like to create Prisma client and push schema to database. I'm using these commands. Prisma client generated. Now I like to push my database schema to Postgres server running in Docker container that we used in our earlier example. pgadmin and Postgres. And if I go to the pgadmin, after pushing schema, I can find new tables, customer orders, order item, and products in my pgadmin. Now let's have a look at our source code. We have to make few changes in our code to make it work with GraphQL and Prisma. The first thing that I like to show is in app module, and here I am importing GraphQL module with a for root method and passing in required configurations. Here my driver is Apollo driver and I am providing a path of a schema GQL file. Schema GQL file will be automatically generated using my entity and DTO classes in the project. Now let's have a look at products, orders, and customer modules. Here I'm importing Prisma module. Prisma module also contain a Prisma service that will be injected into product service, do our CRUD operations or do persistence. Here we have order module, and in order module we have Prisma module. Similarly, if we go to the customers module, we have the Prisma module here. The schema.gql can be written manually or it can be generated as described earlier. In my case, I've started this project and it generated schema.gql from my entities. It will be used by GraphQL to run mutations and queries. It has three parts like types. These types are generated from our entities, and then we have mutations and queries. All of our business features contain DTO and entities. Entities are not required by Prisma as Prisma generate its own entities when we generate Prisma client. However, entities are required for GraphQL. In this case, we have a customer entity and that is attributed or decorated with object type here, imported from Nest GraphQL, NESTJS GraphQL, and we are putting decorator field on all of our properties or variables in our entity. We are decorating all of our properties inside the class customer with attribute field. And in some cases, we are providing the type or some extra information about that particular field. In this case, we are providing that customer ID is an ID. And you can also, here we have order array. A customer contains many orders. And we are telling that this particular field is an array of orders. In the similar way, we have entities inside products and we have class product and the entity is attributed with at object type field. Now if we go to orders, we have order entity. One order can have many order items and there is similar arrangement here. We are decorating our order class with object type and then all the properties with the field decorator, and we have array here for order items and we are declaring that this particular field is an array of order item, and we have order item entity which is quite similar with decorator object type and all the properties decorated with at the rate field. So what I've written here is class product, and in class product we are decorating the class product with at the rate object type, And then we are also decorating each of the properties with @ field. And in this particular case, we are also specifying the type as the quantity in stock, by price, and MSRP all are numbers. So we are specifying the type of field. And in this case, we are saying that it is an integer and we can use float and any other allowed type here. Now let's start looking at DTOs. These DTOs are used for creating and updating particular entity or feature in our case. Here I have DTO for creating customer and updating customer. And in the top of create customer input, I have imported nestjs slash GraphQL. And then I'm importing the class validator for applying the validations on my input. I have create customer input DTO here that is decorated with @put type, which is from GraphQL. And you can notice that all of the properties here are actually decorated with @field. And then I have attributed them with required validation decorators, like customer name is decorated with is not empty and is string. And similarly, if we go to phone number, it is not empty and is phone number. And similarly, other ones like postal code with is postal code. The one thing to notice here is that we do not have any customer ID here, because when we are creating a customer, the UUID for customer ID will be automatically generated as per Prisma schema. So we do not need to explicitly provide customer ID here. But for updation, we need customer ID. And if we visit the update customer input DTO, in this case, we are deriving our update customer input DTO from create customer input and providing in customer ID here and decorating it with the field and defining the type string. The properties it inherits automatically become optional. The same thing remains true for order DTO. Here we are using field decorator with specifics like GraphQL ISO datetime, that is telling GraphQL that the property is of datetime type and it is nullable. Class decorators is optional date, and the rest of them are similar to ones we have seen before. At the bottom, I have decorator field with array of order item input, and then the class validator decorators like is array min size 1. We cannot create order without creating at least one order item. Then we have validate nested. Validate nested tells that each of the order items should be individually validated. And here we have order item DTO. In this case, it is similar. We are attributing it with numerous different decorators that we have used earlier on. The only difference is that we have optional order item ID here that may not be required when we are creating a new order. But each of these items will be validated when we create an array inside order. Here we have the update order input, and it is derived from the create order input with order ID as an extra field here that will be required while updating a particular record. And all the properties inside create order input that are inherited will be optional. And the same goes for order item input. It is derived from order item input, and update order item input contains order item ID. Now it is time to discuss resolvers and services. Customer service is quite similar to that what we have developed in our earlier parts. The only difference is that we are using NESTJS and it is decorated with NESTJS decorator injectable for dependency injection. And here we have the create method, create customer input, that is the DTO. And then we are calling Prisma customer.create and passing in the data so that we can actually create the Postgres record. Then we have the find all. And in this case, we are calling prisma.customer.find many. And similarly, here we are finding one particular customer by passing in the ID that we receive from the GraphQL. And in this case, we have update and we are passing in that which particular customer we want to update and then passing in the values that we want to update. So in the top here, we are actually separating the customer ID and the customer fields. And in the last method remove, we have prisma.customer.delete where customer ID. In this case, we are trying to delete a particular record. The other services in order and product, they are similar. This Prisma service will be automatically injected so that we can call different methods. In this particular create method of order service class, I am separating the order items and other order fields. I am providing order fields and then I am providing the array of order items and informing my Prisma client that I will be persisting these order items in a separate table through this create order items. And finally, I have this include here that tells that I want to receive back stored items so that I can send it back to GraphQL. I have here find all and in this case return this prisma.order find many, which is quite similar to one we have discussed before. The delete method is similar to the customer. Now let's go through the update method here, which gets the update order input and the ID. So here we are separating the order fields and order items, and then we are calling order.update, passing the order ID in the where. Then we have data, and in data I have order fields that I like to persist in Postgres database orders table, and then I have the order items that I like to persist in order item table. Absurd code structure that will allow me to create all of the order items one by one by using order items.map command here and providing in that which particular order item I want to update, and I can create item or I can update item. Product services.ts is quite similar to orders and customers, and it is also getting Prisma service injected into it through the module. Now resolvers act as the bridge between GraphQL and our services. Resolvers bind mutation queries of GraphQL with methods inside our customer resolver class. Here in this resolver class, we are decorating the customer resolver with @resolver decorator and passing in the entity. We are using the dependency injection to inject customer service class into this resolver so that we can delegate the calls to customer service. We have two different type of method decorators here, @mutation and @query. The mutations are linked to resolver methods through this mutation decorator, and queries are linked with query methods through query decorator of GraphQL. And here we are trying to convert or transform the arguments that we receive from GraphQL into our custom DTOs. In this case, we are converting create customer input argument into create customer input DTO. We have methods for find all, find one, update customer, and remove customer, and each of them are delegating calls to customer service. Similarly, we have order resolver that acts in the same manner for the order entity or order business function, and that remains true for the product resolver as well. And we have product resolver here. So we have seen the functionality of resolver classes. Now let's run this application and test it using GraphQL Playground. Started compilation. Now my application is running. We can access GraphQL Playground on our local host after running this application using localhost 3000/GraphQL. I have already created few tabs providing queries and mutations for the product table here. Let's go through them one by one. To get all the products, I'll be using this query with the products and all the relevant fields or properties that I want to get. GraphQL provides documentation of all the queries and mutations, and it is automatically generated for you. This can help you to write your queries. And here I have the product with ID and product name, vendor, and all other information that I need. Similarly, you can find details about mutations as well. It gives the detailed schema here as well, and I can copy paste. Now let's run this query to get all the products. I created few products earlier on and I have the products here. Now let me copy this product UUID here, test product 1, and I am in get product. I am pasting this UUID here and I can get the test product 1. Now I can go to the create product and I want to create a third product here. Maybe its name is mouse. Any company. And maybe some other values here. So let's run this mutation. A new product is created with this UUID, mouse, any company. Now let me copy this UUID here and go to update product. I'm pasting the UUID for the product. Maybe I leave it like this. So I'm changing the product name here. I can remove all other ones that I don't want to change. Now you can see that I have changed the particular product name and I like to remove this product. I copy the UUID and go back. In remove product, I can paste the UUID. Product is removed successfully. Let's use Postman to test GraphQL API. And this time I'm using GraphQL here. And let me pass in the URL localhost GraphQL. And interestingly, it will automatically load all queries and mutations for me. For the products, if I like to query all the products, I simply have to select these products and run the query. That simplifies things a lot. But in this particular case, I like to test customers and customer mutations. So let me pick customer here. So let me change few things here. Let me change few things here. I'm ready with the mutation, and new customer is created, Mickey Mouse, and I'm going to get all the customers here, query, going to select the customer query here, getting all the customers and run it here. So I can see all the customers in my Postgres database table through GraphQL API. And here is the Mickey Mouse. Let me copy one particular UUID and paste it here and run the query again to fetch one particular customer based on ID. It should be the same. So I have one customer here. Now I want to try customer update mutation. Update customer, and here I'm pasting a pre-written mutation, and I have this UUID for Mickey Mouse. Delete unnecessary fields. Maybe XYZ ABC here, and I'm running this. Address is changed here. Now I like to remove customer that I just created. Remove customer here, and here I am providing the ID, the same ID we have below here for Mickey Mouse. And let me run the query. So remove customer was executed successfully. And now let me get all the customers to check if it is removed. I'm selecting customers here, removing this mutation part and executing it. And we have three records: Pink Panther, Max Planck, Jane Doe, but there is no Mickey Mouse. So let's try out create order here. And I have created the mutation with the customer ID and specific product IDs here, along with the quantities that I need, and set paid to true. And in comments, I have the third ID here, third order here. And let me query this. So order is created with the specifics. And if I get all the orders, in this case, I'm getting all the orders I have in database. And here we have the third order with the true. I'm not returning order items at the moment, but I can do it by updating my order service. This is end of the part. Stay tuned for the next part.